Hi there, welcome back. Now let's take a look at an example of a chi-square test of independence together. So imagine that we had this research question. Is planning to become a therapist associated with planning to go to graduate school? Certainly stands to reason that those that are thinking about becoming therapists in the future may also be thinking about going to graduate school because that is typically the level of training that you need in order to become a licensed therapist. Now, the association could certainly be in the opposite direction, where those that are thinking about going to graduate school may be open to a type of career that is that of a therapist. And so, regardless of the direction, we're thinking about a potential association between those ideas. Now, what are the independent variable and the dependent variable? And so we might think that the independent variable is planning to become a therapist. And so that is the therapist variable in our data set. Whereas the dependent variable will be planning to go to graduate school, and so that is the grad school variable in our dataset. Now, what would this look like when we actually translate things into hypotheses? And so the null hypothesis would say there's no association between your IV and DV, whereas the alternate hypothesis would say that there is indeed a significant association or effect in between IV and DV. Now let's translate that into the variables that we have. So the null hypothesis might say something along the lines of planning to become a therapist has no association with whether a participant plans to go to graduate school. So no association between the independent variable and dependent variable. So what might the alternate hypothesis look like? So you may have said planning to become a therapist has a significant association with whether the participant plans to go to graduate school. And so now we anticipate a significant effect between IV and DV. And so let's take a look at testing this hypothesis in RStudio. Now, before we get there, some things that are good to do to get ready. And so I'd encourage you to follow along. But first of all, a good first thing to do would be to save the clean version of your Psych 300 dataset in your working directory, wherever it may be on your machine. And then go ahead and start a new RStudio session where you set working directory to point to that location. And then go ahead and import the dataset and also install the gmodels package. And then we're ready to go and start running analyses. And so I'll meet you over in RStudio. See you soon. So here we are in RStudio, and what I'm going to do is to go to packages and then install that gmodels package. All right, and so I think I may be all caught up with you. Now, first of all, I'm going to attach my data set. Poof! And so if you're wondering why my console changed character right now, I've had some recording issues on my machine, so I had to restart the session. And so I do apologize for the all of a sudden you're seeing something different in my console. Technology is not exactly my friend today. It's one of those days. But let's say that now we're thinking about taking a look at the relationship between our independent variable and dependent variable, so therapist and grad school. And a good way to eyeball it, first of all, is to maybe run a CrossTable or crosstabs. Now, the most basic way to run that would be a table function. And so let me show you what I mean. And so table function will ask you for the row variable and the column variable, basically what should go into your table. And it will literally create a map of the number of cases that belong to each cell. And so basically your contingency table, if you will. And in this instance, we have the variable therapist, and then we also have the variable grad school. And so let's try running that. So that's very nice. Now we have a very nice table of the number of cases that belong to our 2x2 table. And so, for example, 74 people said yes to both variables. 17 said no to both. And then you can see that 7 people said, yes, I'm going to be a therapist, but no, I'm not planning to go to grad school. Whereas 16 people said, no, I'm not going to be a therapist, but yes, I'm planning to go to grad school. And so pretty fascinating. Now, just as a caveat, this is my data set, so your numbers will look rather different, but you will be able to use the same function to get a similar table for your own data. So you can run the code. Now, we had installed that gmodels package, and so let's see it at work And so here we are with my insanely fast typing. Someday I should call the Guinness people. Now, so remember that we had installed gmodels package, but we had not actually loaded it. And so I'm just going to do library gmodels, and I will run it before I run a function called CrossTable. And CrossTable will once again take on the same type of argument, and so we'll tell it therapist and grad school. And so let's try running these. Wow, what is this? And so you may recognize some of the numbers that you've already seen in the table function, but pretty fancy, and there are a whole host of numbers. What is going on? Now, if you scroll up a little bit, then the printout here helpfully tells you what each cell contains. And so there's the n. N would be the number of cases that belongs to that cell, how much of a contribution makes the chi-square, and then percentage of the row total, percentage of the column total, and the percentage of the table total. And so you will see, for example, that here you can see among those that said, no, I'm not going to be a therapist, 52% basically said, no, I'm not going to go to grad school, whereas 49% said, yes, I'm going to go to grad school. Whereas these are column percentages right here. And so among those that said, no, I'm not going to go to grad school, 71% basically said, no, I'm not going to be a therapist, whereas 29% said, yes, I'm going to be a therapist, and so on. And so you can take a look and see how things add up in terms of percentages or proportions. All right, so it's good and well, but we're still waiting for that chi-square test, aren't we? And so let's move on in there. So I gotta say, you know, my typing just has increased to infinite speed, it seems. And so chi-square test of independence can be run using the chi-square.test or chi-sq.test that you're seeing in front of you. And we'll run the basic version of it, and then we'll make a correction to it. And so what you put in the parentheses is pretty similar to what you have done before, which is your row variable and then the column variable. And so let's try running that. And here we are. We've got our first chi-square test. Isn't that exciting? Amazing. Now that's really interesting that we get a Pearson's chi-square test, but it says with Yates continuity correction. Now what that means is that by default, this chi-square.test function is making a correction for smaller sample sizes. And so typically smaller sample sizes under 100 or so. Now you know that our sample size is greater than 100, so we actually don't need that correction. And so we're going to actually turn off the Yates correction. And so let's do that. And in order to do that, we can use the same function again, but this time we just tack on a statement that says correct equals false. And then you can run that. And now you get a Pearson's chi-square test, but notice that it doesn't say with Yates continuity correction. And because our sample size is large enough, I would use the result from this chi-square test, not the one with the Yates correction. Now all this is well and good, but when you write out your statistics in APA style, typically you have to report a specific p-value. Or if it is a very small p-value, then you would do p is less than 0.001 kind of a deal. So you might remember that from earlier statistics classes. Now, when you get a p-value that looks like this, you may be wondering, what the heck is this? How do you write this out in APA style? Because this is usually not something I've seen in APA style. And if you're thinking, I don't recognize this, you're absolutely right, because that is written out in scientific notation. And so I would say, you know, if you're familiar with the scientific notation, great, go ahead and interpret this. But if not, then one good way to get around that would be to ask RStudio to translate that for you. And so let's take a look at a way to get RStudio to translate that for us. My typing speed, I tell ya. And so what you can do is to just use this format function, and you can just copy this value. What is this? Okay, and so copy this. So you tell R, this is the value that I want you to format for me. And then you just say whoops, I know how to spell, I promise. Scientific equals false. So basically telling R, you know, please turn off the scientific notation and give us the actual number. And so let's try running that. Ta-da! And so, wow, it is a very, very small number, isn't it? And you can probably tell by looking at the fact that number one, it's in scientific notation. But it is also, you have the negative -07, -06, so it is telling you, sort of that it is a very, very small number. Regardless, you can just ask R to format it for you, and you see that the p-value here is incredibly small. And so let's take a look at all of this and see how we might write it up in APA style. And so let me meet you over at PowerPoint. Gosh, when I say PowerPoint, that sounds like a really lovely place to meet, doesn't it? Like Sunset Point or Greenpoint, for those of you that may be familiar with, say, an area of Brooklyn. So here's a result for the Pearson's chi-square test. And I think the numeric values that are being shown here are pretty self-explanatory, but to break things down, here is the chi-squared value. Here's the degrees of freedom, just one. And then here's the p-value. And so when you interpret this chi-squared test, first of all, you might notice that the p-value is less than the alpha of 0.05. Now, do note that alpha is typically set to 0.05 by convention in psychology. And so unless specified otherwise, we can use alpha equals 0.05. Now, p is much smaller than alpha of 0.05. And so in that instance, do you retain or reject the null hypothesis? If you said reject, you're absolutely right. And so p is less than 0.05, and so we reject the null hypothesis. And so let's translate that into APA style writing. And so you might say something along the lines of, planning to become a therapist in the future was significantly associated with whether or not the participant planned to attend graduate school. And then this very elaborate way of writing up the chi-square test result. And so you may be wondering, what are all these numbers about? So one is the degrees of freedom right here. And then you report the n, the number of cases you have. Here's the chi-squared value, and then here's the p-value. Now, looking into this further, this is a chi symbol with a superscript 2 to indicate chi-squared. And then there's no space. You just immediately start with a parentheses. And then 1, comma, and then there's a space here, capital N to indicate the total sample size, space equals space. There's always a space before and after an equal sign, so remember that. Space equals space, the N, and then immediately close the parentheses. Once again, space equals space. Your chi-square value, this time I rounded it to the 100th place, which is pretty commonplace, comma, and then space, italicized lowercase p to indicate p-value, and then space less than space, 0.0001. And so this is how you would write the result of a chi-square test in APA style. It's one of the more complicated ways to write up statistics, I would say, but it's good to know what's in there as well as how to write it up. Now, you may be wondering, how do you get some of those fancy schmancy symbols? Here are some tips for your Microsoft Word. You can use the Home tab, Font area to go ahead and find superscripts or subscripts. You could go to Insert tab and then go to the Symbols area to find Greek symbols, including the chi. And so these are a couple places you might want to know when you're writing up your APA style results. Now let's talk a bit more about writing up your p-value, because that's something that's going to happen time and time again. And so first of all, remember that p-values are indicated using italicized lowercase p. P-values are typically rounded to 2 or 3 decimal places, so 100th or to the 1000th place. And there's no 0 before the decimal point. And so instead of writing 0.01, you want to write 0.01. So there's no 0 to the left, because in APA style, quantities that always fall between -1 and 1 will not have that 0 before the decimal point or to the left of the decimal point. If you have a small p-value, let's say under 0.001, then go ahead and use the less than sign. And so you saw an example of that. And if you have, RStudio showing you a very small p-value, you may see that in scientific notation as you saw. But it's indicated like this, lowercase italicized p, and then space, and then the less than sign space, 0.001. For all other p-values, go ahead and use the equal sign. And so here's an example. If your p-value is 0.70, then here, lowercase italicized p, space equals space, and then 0.70, like that. All right, so now here comes the exciting part where it's your turn to run these analyses. Woohoo! And so using your cleaned Psych300 Data 1 dataset, please examine the same question that we examined in lecture. So hopefully it's pretty easy to translate what you saw me doing to what is happening in your RStudio. But go ahead and follow the procedures that were demonstrated in this lecture video. And then I'll be curious to hear more about it in the review questions. All right, that's all for now. Have fun, and next time we'll talk about the chi-square goodness of fit test. So great job today, and enjoy running your own analyses. Take care and talk to you soon. Bye for now.